Okay, cool. So the live stream is now up. For those who weren't here in actual class, what we just did is we imported Kalim's superior world generation algorithm, and we're going to test it. So this is the something a student of mine made, and this generates a world around the player. And by the way, can I point this out? This actually might be a good opportunity to do some performance testing and test how performant this is. One thing that I really like about the way that you design this, Kalen, is just the despawning of things. You considered the fact that yes, this is a game. It could be an open world game, but you can't have everything loaded there. In fact, if you do, you're going to run into major performance issues. So that was really, really smart, and I think we're gonna test out the FPS. And right now, okay, so right now I'm hitting 27, 28 frames per second. Mind you, I'm also running Minicam, which is super GPU intensive, which is why I need to replace it. I'm running a Google Meets, which is really actually very costly as well. And this is pretty good. So as I move forward, you see the world is spawning in front of me. You can adjust the render range. Oh my gosh, even better. That's awesome. Okay. And the world is despawning back at me. And how many and it's really doing it in these chunks, which I love. How many blocks to a chunk? It looks like each chunk is like a square, right?
Yeah, it is. I would say about it's like 5 by 5, I think,
Okay. Hmm.
or 16 by 16.
Okay. Another little trick here. What I'm gonna do is I'm gonna set a color to the folder here. The folder that Caleb gave us. I'll set it to like pick a color, Caleb. Color
I
should
mean, I had it as green in mind, so may as well be green.
green it is. Alright, got a green folder. Um Yeah, Chris, I know you. I thought you meant Minecraft. Hey, well, if it's 16 by 16 in Minecraft, we should probably maybe do that in here. We'll make our chunk size identical, maybe. Could be good. I want to mess with that render distance real quick. So that would be on player controller, I believe, right?
Yeah.
Okay. And then is it a variable? Render range. So that's 5 chunks. So if I set it to 1 chunk, I should have a very small world in front of me. Yes, but as I walk forward, yeah, oh, just about as I get to the edge, it starts right before I fall over. Really cool. Great. Oh my gosh, I love it. Okay. So some of the things that we need to actually solve on this generation algorithm. And I really like this. I think this is what we're going to spend some of the next couple classes on, kind of figuring out, debugging, and messing around with this procedural stuff. And remember, we can always come back to the fact that we have a character that's a creeper that we play, that we can, trigger explosion, cancel explosion. We got the flashing effect as well on his, material. We've got some basic NPC stuff, but this will be really nice because we're going to at least have an environment, especially once Destiny gets us our textures, an environment that looks and feels and behaves like Minecraft, including, hopefully, procedural generation. Oh, and don't forget, we also have blocks. We have blocks that have health and blah, 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 and all that. So let's see if we can integrate the blocks into Calem's thing right now. So Calem made a generic block, I think, probably, for spawning stuff. This is my block, I believe. Yeah, her block and stuff. So let's see. Yeah, Caleb, what are you spawning? Is it static mesh? Is it a blueprint called block?
It's a static mesh
Static mesh,
at the
cool.
moment.
Is it regular static mesh or instant static mesh?
It's an instant.
Oh, okay, gotcha. So again, that was good considering performance. So I was hoping to say static mesh because I was gonna be like, well, watch this, folks. But he's already using instant static mesh, which is although I could pull a hierarchical instant static mesh out of my sleeve, which is like even a better instant static mesh. You can Google what that is, hierarchical instant static mesh. So yeah, let's take a look at what he's spawning. If I want to find, again, I do this a lot where I look at people's code that I didn't write. I do that for, usually when I'm doing development for another company or something, They had some other developer who either left and now I'm there, or they have another developer who's been working on something, but they're adding me onto the project. And anyway, I have to look at Unreal Engine projects that I've never seen before with lots of code and trying to debug what are they doing here, what's their style there, that kind of stuff. So one of the things just a trick I like to pull up is if I want to find out what it is Caleb's spawning, and I don't know where it is in all this code, I'm going to do right here, find results, which you can get by doing Control F. And I'm going to type in spawn actor, because I know spawn actor from class is really the only way that you can spawn something. So we'll find only the nodes that cause spawning to happen. There we go. Spawn new chunks and render, spawn new chunks within render range. So that must be it. Oh no, that's a function he made. So we'll go through the list until we find something. There's our spawn actor, MC chunk. We open this up. So this is a blueprint itself, which has, it looks like one instance static mesh. And he's adding the instance, making transform, his local space. Yeah, I'm just checking on the code, block size. Okay, Caleb, I have another question. Why are we dividing, what's this? Block size divided by 100 times 1 to be a vector.
That there is helping when it comes to the chunks, because it would set an overlap and it was driving me insane, because I would try to adjust the block size because it wasn't big enough or small enough, and I would adjust it, and every time I would adjust it, it would be like, so the blocks are spawning on top of each other again. Have lag.
Oh, really? Interesting. They're all spawning in the same spot in this. Okay, that's good. That's one way of spawning it. You said that they were overlapping, like their location was off, or it was just that their scale was.
Yeah, like it's every time the location was off, they would overlap and spawn basically on top of each other, and it would just repetitively, continuously spawn until it would just crash.
Gotcha. Okay. There is also there's a node that's helpful. I don't know if it helps in this area, but it's great because it's built into the engine called Snap to Grid. And so basically you put in a location. Oh, there's one for vectors as well, I think. Snap Grid. Yeah, vector snap to grid. So both these nodes. So it will, you say, hey, my grid size is 100 or 50 or something. And whatever weird, random, crazy number with decimal that comes in, it spits out a number snapped perfectly to that unit size. Don't know if that solves that, but that's a good thing to know for anybody who's doing that kind of thing. All right, so looking at MC Chunk. So MC Chunk, let me ask you. So, Caleb, MC Chunk here is multiple. It's all 5 or 5 by 5 of your little cubes, right?
I believe so.
Yeah, I think it is, because you have a for loop going on here, and then the for loop decides to then add an instance of the static mesh thing. Okay. So what I would do is I would potentially, we'll try this, replace this part of the code with our blocks, the ones we made in class, the blueprint, okay? Which means we're not going to be using add instance anymore. Oh, performance, oh no. But here's the thing. Remember, our block, here it is already doing an add instance node. I'm doing a slightly different add instance node where it's based in world space. I like Caleb's better, just saying. But that's what we're doing there. Okay, so let's try spawning the actor, this actor called block. Okay, so back to chunk. Here we go. Spawn actor from class. We're going to type in the name of our blueprint called block. And remember, on our spawn node, because we exposed this variable called block type as something that's accessible to us, we can actually switch around and say, dirt, grass, stone, or do something random, right? Right now, let's just do sand, so that we'll see it immediately and know, okay, that's the way it looks. Actually, no, let's do gravel, because our sand doesn't look like sand. We're going to plug in Caleb's exact same wacky, crazy, brain of a madman style code here that works. So I ain't complaining. We'll bring that in over here. So now we're spawning the blueprint instead of the instance. See if it works. 3, 2, 1. All right, we'll move forward, and my frames.
You still have the chunk size really, really low.
Oh, that's right. That's right. I did make chunk size really, really low. I am also, though, it seems like it didn't compile the material or something. I'm like, so it might need a second to compile the material, or we can just set it to grass and see if that works. Let's bring out a block real quick for reference. Okay, so there's one block. We'll put it in the sky so it doesn't get hit by our algorithm. All right, so let's fix the blocks, not block size, it was chunk render range or something, right? Render range, and it was 5 originally, so it was 5 chunks.
Yeah, I had it at 5.
Gotcha. We'll do 5 for now. You know, once we can optimize, we can go up to 16 or something. All right, hit and play. It's taking a minute. Uh-oh. Oh, okay, cool. It's grass all at the bottom. So the performance is wonderful. And by wonderful, I mean the opposite of wonderful, in case anyone didn't know. But we know that we are spawning our block. Okay, so we may need to amend how we do our code. We may know, maybe we don't want to do a blueprint, but instead we want to do what's called a component, which is like an invisible event graph you can attach to anything. We can attach it to an instant static mesh. In fact, a lot of games that use like a lot of trees and stuff, foliage, in a level, they have those foliage and those tree things as static meshes, or sorry, instant static meshes, right? The type of static mesh you promise the engine, hey, I'm not going to modify, I'm not going to move it around, it's never going to leave, it's never going to move, it's not going to have physics, and then it gives you performance back in return because it doesn't need to be ready to calculate all the stuff about your instant static meshes that it normally does about regular static meshes. Okay, so when it comes to an instant static mesh, you'll see a lot of games, like for example, The Forest. Anybody play The Forest? You guys know what The Forest is? I see Christian nodding his head, maybe. Forest, great game, horror game, super scary, super fun multiplayer game. You're on an island, you gotta find your lost daughter, there's these horrible mutant cannibals that want to kill you, and it's like a crafting survival base building game. So you have chop down trees around the forest. But these trees are all instant static meshes. The game was made in Unity, by the way, but it's the same concept. They're all foliage, they're all these like lightweight things. So how do you add functionality to something that, like in our case, it should be an actor, it should be a thing that has code on it, that's able to kind of do things, right? But if you have, an entire forest of these things, like we're having an entire forest, so to speak, of blocks in our world, when we spawn them, you're going to lose the performance. But how do you get the functionality where you can actually chop down trees and they grow back and things like that? Well, the way that you would do it is you would, instead of making the thing actor, you'd leave it as an instant static mesh. You tack on this little component. It's called a component. And you can make them, and it's kind of like this free-floating code or event graph. And you can do something as simple as like, hey, only activate only make this component active whenever the player is within 50 units, 50 centimeters of this tree, right? And that kind of thing. So maybe we're gonna go the component approach. So we saw that. Let's go back to Calem's thing and see the performance there. So much better. Yeah, because I was like, well, sometimes I notice at the end of a class, my performance starts to go really bad. But if I do this, it's taking a lot longer to start. A lot longer. And the performance is objectively worse. Okay. So that's okay. These are the sorts of discoveries that you make during development. We've done the Minecraft thing, and I've done it before, but not on a real large world. And the whole point of Minecraft is it's on a real large world. So we're going to have to find a way. I think the component approach is going to be the way we do it. See, now I can move around and have fun. I feel like I'm really here. Of leveraging this instant static mesh, or maybe we could go hierarchical instant static mesh, I don't know, with, see if that comes up. Yeah, see, this is the hierarchical instant static mesh. It looks and behaves the same. So the difference is I'd have to read up on it, but something to know. I guess it has built-in culling, which is great. So it will de-renderize itself, as will the these. And by the way, this is another good thing about instant static meshes and hierarchical instant static meshes is when you click on them, look at this: instant start cull distance and fade distance. So in addition to you spawning out the chunks, we can specify these individual instances, these individual instant static meshes to turn off and turn on, and that kind of thing. So yeah, I think we're gonna do a component driven approach. Where basically we'll get this instant static mesh and we'll type in, let's see, add component, spawn component, and attach. I think it's attach component. Attach component. Yeah, attach actor to component. No, attach the root of this actor, this Y component. Yeah, that would work. It should work as well as the other one because this has a component as well. Add component to component. Yeah. So something to think about for next time. Don't have enough time to get into it this time. But we will, then the notes, make a component on which all of our code lives. So no longer dealing with blueprints. Okay, the blocks in your world won't be blueprints. It'll be super hyper efficient, totally lacking features, little ghosts, little digital ghosts of a mesh. That is until you get really close to them, or until you start hitting it, and then you start applying functionality onto it. You can think of it like that. Even is your and one way people do it too, and this is like the forest, is you start hitting like you got this instant static mesh that's useless. It can't do anything, but it looks good and it's super efficient sitting there. But as soon as the player gets near it or starts hitting it, what you do, this might be exactly how the forest works as regards the component thing, is instead of attaching the component to that instant static mesh kind of thing, you remove that instant static mesh and you replace it with a blueprint that has the exact same mesh in the exact same transform and looks exactly the same. So the player, simply by interacting with this object, you in code, like a little magic trick, swap out this instant static mesh you can't do anything with because you have to have thousands and thousands and thousands of them, so they just sit there in the world looking pretty. As soon as you start hitting it or getting near it or interacting with it, now you delete that from the world or hide it and remove it, and you spawn in something that looks exactly like it. It's actually less performant, but has all the goods, all the good stuff you want to be able to do with a static mesh, right? Or a Minecraft block. That's probably what we're going to do it. So, for the notes, where are we going to put this? When we next meet, we shall continue development on the world gen, including a component / blueprint that spawns on blocks interacted with, and eventually random height seed. Okay. All right, that's about it. Any questions on any of that material? Okay, so remember, guys. Yes, Destiny. If you get the textures by within the next 2 classes, that would be great. Next class, I'm not gonna be able to do much with them, but if you get them to me, we could at least throw them on and test them. I can tell you whether they're gonna work or not. But yeah, give me those textures. Game Club. You guys know about that? Game Developers Club? Our after school club? I sent out an email last night and then also on Friday. Our first meeting is today at 2 o'clock. So for those of you who are really interested in meeting your other fellow game developers in the program and at school, and forming teams and forming development teams and game jams and all kinds of stuff, the inaugural meeting is today at 2 o'clock, okay, from 2 to 3. I sent an email with an attachment that has the Google Meet code on there and everything. So hopefully I'll see you there if that's something you're interested in. And if not, I will see you next class. Other than that, bye-bye.
So, see, I'm gonna go, but it's gonna be really weird because normally when I'm in a club, I'm running it.
Ah,
So I have to get used to that.
what clubs?
In middle school, I ran my own clubs. Like, I ran a Yu-Gi-Oh club, a game development club, and a P7 club.
Well, I actually could maybe,
P7.
I could use your help, really, Kaylin, because I want this club to be student run but teacher monitored. So rather than like class where I'm like, all right, guys, here's what we're doing today. I really want the students to run it, and I'll be there to provide the value that I can and to monitor. So right now I have a handful of students who are helping with it. Mainly Michael Rowland, who is a senior, and you'll see him in the meeting. And yeah, I would love to have you be part of the students who are running it.
Yeah, yeah, the game development club in my middle school, we used Khan Academy
Oh, really?
because
Okay.
it's what we had. It was the program we had. It's online, so you
Yeah.
can do coding online. It was, yeah, we got